9702 May June 2015 paper 1 and the uh, topic is power. Uh, and the question number is 19. This question is a very difficult one because mostly students pick C as an option, which is very close to, or we can say, a concept linked to this thing. But the answer is B. So why? Let's discuss about it. A conveyor belt is driven at velocity v by a motor. Sands drop vertically on the belt at the rate m kilogram meter per second. So m is the value, kilogram meter per second. What is the additional power needed to keep the conveyor belt moving at a steady speed when the sand starts to fall on it? So here is a conveyor belt, it is moving, and the sand is falling from the top, right? So when it is dropped on the belt, right, there is a sudden jerk, and there may be a change in the power of the belt. But in order to keep, whenever a jerk, an additional power is needed. So that we need to calculate. Keeping in view that it is moving from top to bottom, right? So it may involve the change in kinetic energy, right? But the kinetic energy is actually from top to bottom, right? And the belt is moving horizontally. So that is the key point which reflects that C is not a good option. Why? Because there are so many things involved in, like the sand has grains in it, and grain has a change a grain must also have a kinetic energy. So these things not involved in it. So what should we can do now? The power is it for the horizontal. The force which is needed to make the steady speed F into V. This is another formula of power is this. So formula is in M times acceleration means velocity upon time into velocity or speed. So velocity m upon t, they says m upon t is m upon t, mass upon t is m. So we switch m upon t with m, and v multiplies v square. So it is mv square. Option D is the right answer. But if we consider a kinetic energy thing, right? Kinetic energy upon time, we should get this half mv square. But the thing is, if we consider this, which is a vertical movement, it will affect more things to be considered, like the kinetic energy of the sand inside in from the form of grains, and and the jerk, and the rate of change of acceleration as well, because the acceleration is changing, which is called jerk. So this is a will be a very typical question, right? So this thing gives us an incomplete answer. This is approximately completing this because the body is moving from body is horizontal, and the force which is needed to support the jerk is F, right? It covers horizontal and vertical net force, and this is V, which is moving horizontal. So this is the formula we can use to find out this question, but this is a difficult one question.